This is Fluid Coding and AI. Today is not another Gemini model review. We are building the same technical research agent 3 ways, and the question is sharper. When an agent cites the web, do we trust the model, the search layer, or the audit trail behind the answer? The agent task is simple. Answer technical research questions with current facts, useful citations, and enough evidence that another developer can audit the answer later. That means the scorecard is not just accuracy. I care about freshness, citation precision, live URLs, query history, extracted evidence, cost, latency, and what happens when the question contains a false premise. Because in production, a citation is not decoration, it is the receipt. Architecture 1 is the native baseline, Gemini with Google Search grounding. The app sends the user question to Gemini with the Google Search tool enabled. Gemini analyzes the prompt, decides whether to search, generates one or more search queries, processes the results, and writes the answer. The useful part is that the response can include search calls, search results, and inline citation annotations that map URLs to spans of generated text. For a grounded Gemini app, that is the lowest friction starting point. The trade-off is control. With native Google Search grounding, Gemini owns a lot of the retrieval workflow. That is convenient when the product needs a fast answer with citations. But it is harder when the product needs deterministic evidence collection. Maybe you need to cache the extracted pages. Maybe you need to route the same evidence to a second model. Maybe compliance wants to know which query created which claim. If the model searches poorly, the application may not have enough retrieval detail to repair the search step cleanly. Here's where my expectation changed. I used to treat web grounding like a mostly solved product feature. Turn on search, get links, move on with your life. The research is messier. Academic and journalism tests keep finding broken, fabricated, or weakly supported citations in AI search systems. One 2026 citation study found hallucinated citation URLs across commercial LLMs and deep research agents. The TOE Center found many AI search answers to news citation queries were simply wrong. So the reset is this: the citation is not the finish line. The audit trail is. Architecture 2 uses parallel. There are 2 ways to think about it. Inside Gemini Enterprise, Parallel can be used as a grounding source for Gemini. Google announced that integration on July 16, 2026, and the docs mark it as preview and pre-GA. The more explicit architecture is Parallel First. Call Parallel Search, Extract, or Task, store the evidence, then ask the model to synthesize from that evidence only. That separation is the interesting part. Parallel is positioned as web infrastructure built for AI consumption. Its search API takes a natural language objective and returns LLM-optimized excerpts. Extract pulls clean markdown from URLs, including JavaScript pages and PDFs. Task is closer to a multi-hop research agent, with cited structured output and a basis object behind the answer. For a developer, that changes the shape of the system. Retrieval becomes an artifact you can inspect, cache, post-process, and reuse. That is boring in the best possible back-end engineering way. The public benchmark story is promising, but not settled. Parallel publishes strong first-party results for Parallel Turbo and its Task API family. In those tables, Parallel often looks cost-efficient and sometimes very accurate across multi-hop and simple question benchmarks. But the same research notes matter here. These are provider-published runs, often LLM-judged, against live web systems that shift over time. OpenAI Web Search beats Parallel on some accuracy. Only headline scores in Parallel's own search turbo tables, while costing more in those disclosed. Architecture 3 uses Exa. Like Parallel, Exa now appears in Google Cloud Docs as a grounding option for Gemini Enterprise. It is also marked Preview and Pre-GA, and it requires an Exa API key in the Gemini request. The direct Exa-first version is especially interesting for technical research agents. Exa can search semantically, return highlights, summaries, full text, grounded answers, and structured outputs. For coding-heavy research, Exa Context targets GitHub repositories, docs pages, Stack Overflow posts, and technical sources. Exa's biggest architecture benefit is control over the context shape. In the Gemini grounding docs, Exa supports options like fast or automatic search, include and exclude domains, maximum highlight characters, and the number of grounding results. In the direct APIs, Exa can return dense on-query highlights instead of dumping page boilerplate into the model. Exa Deep also describes structured outputs with field-level citations. That matters when the agent has to explain not just what is true, but which exact field came from which source. Exa also publishes big benchmark claims. Its Deep Max material claims very high scores on Deep Search QA, frames, and HLE search, with much lower latency than some compared systems. That sounds impressive, but the caveats are important. Some numbers are chart-based rather than backed by raw run artifacts in the page text. Deep Max availability and pricing should be rechecked before a production recommendation. And Exa's own eval writing admits retrieval evaluation has grading variance, prompt dependence, non-determinism, and a verification gap. Honestly, that last part makes me trust the discussion more. The clean test is to run the same agent prompt through all three systems. Ask something like, what changed in the latest LangGraph, Gemini, browser use, or Vercel AI SDK release, and which code path should I update? Then require the same output every time. Claim, source, exact cited span, retrieval timestamp, confidence, and what would falsify the answer. That prompt forces the architecture to show itself. Is the evidence reusable? Are the citations exact? Can a reviewer reconstruct the path from query to source to claim? Here is the practical comparison. Google Search grounding is the best default when you want the simplest grounded Gemini app. One model call, broad web coverage, native citations, and fewer moving pieces. Parallel is more interesting when the agent needs reusable evidence, extraction, caching, multi-hop research, enterprise workflows, or multi-agent handoff. Exa is more interesting when the agent needs semantic technical context, domain controls, token-efficient highlights, structured outputs, or field-level citation mapping. None of that proves one is universally smarter. It shows which failure. There are costs hiding behind the nice diagrams. Google's native path can build based on search queries the model decides to execute for Gemini 3 models, which means the model's search behavior becomes part of cost control. Parallel and Exa add their own provider boundary, keys, billing model, data sharing questions, and operational dependency. Parallel docs explicitly warn that derived or rewritten queries can be sent to Parallel for processing. More control is useful, but it is still more surface area to secure, monitor, and explain. My verdict is simple. Start with Google's search grounding if you need a fast-grounded Gemini product and the audit requirements are light. Reach for Parallel when the work looks like research operations, multi-hop questions, extracted evidence, cached sources, multiple agents, or a reviewer who needs the basis behind the answer. Reach for Exa when the work is technical and semantic, docs, repos, code context, domain filters, structured answers, and field-level citation trails. But do not outsource trust to any of them. The real product feature is not has citations. The real feature is can prove the answer. If this helped you think more clearly about grounded agents, like the video and subscribe to Fluid Coding and AI. The next time an agent hands you a citation, do not just ask whether the link exists. Ask whether the system can prove why that link belongs there.